In this lesson, we'll be trying to tackle three materials with similar functionalities. We are going to be discussing CarPaint material, CarPaint Flakes material, and Stochastic Flakes material. In the scene, we have this partial car to be able to show how the CarPaint material works, but I have deleted most of the car parts as we don't need them here. Also, we have this backdrop and also one V-Ray dome light to light our scene. If I select the light and drag its texture to the material editor, we are using this free HDRI called Brooklyn Bridge Planks, which you can find on hdrlabs.com. Okay, in the material editor, let's add a new CarPaint material. In the Scene Explorer, select this group called CarPaint and assign the material. And if you take a look at the render with the default state of this material, you see we get this nice car material even though it still needs work. Now let's get back to the CarPaint material itself. This material obviously is here for rendering metallic CarPaint, and it has 4 layers. We have a diffuse layer, a glossy reflection layer, we have a metallic flakes, and a clear coat layer. So we have our base diffuse color, then we get a blurry or a glossy reflection layer on top of that. We add the metallic flakes layer, and on top of everything we get the clear coat reflection layer. In the base layer parameters, we can control our base diffuse and glossy reflection layers. Base color controls the diffuse color, and as I'm changing the color, you can see how it affects the material in the preview. Let's use a white color with the value of 240, and you can see the result in the render. Maybe we can try a red color like 231, 5, and 2, and this would be our render. And you can see how the base color is the main color component of the material. Now let's set the base color to its default, which was 77, 102, and 128. Base reflection is the amount and strength of the reflection for the base layer. In the first render, base reflection was set to 0, so no base glossy reflection, and the sharp reflection we see is coming from the coats layer. The base reflection in the next one was set to 0.5, and finally 1. Let's set it back to 0.5. We have our base glossiness, which controls how sharp or blurry the base reflection should be, and because we are rendering this metallic CarPaint, the base reflection should be blurry and matte, so 0.6 is a very good value to start with. But in the first render, base glossiness was 0.6. Then we have another render with 0.8 and finally 0.95. You can see how the base reflection becomes sharper as we increase the glossiness value. Let's set it back to 0.6. We have base trace reflections. When disabled, the base layer only produces specular highlights, but no glossy reflections. Next, we have flake layer parameters, and obviously this rollout controls the appearance of the flakes we see in the material. One important note before going through the parameters for this rollout is you need proper UVs on your model to see the flakes, especially when the mapping type down here is set to explicit UVW channel. Flake color controls the color of the flakes, and it normally should be a more saturated, more vibrant version of the base color. And as I'm changing it, you can see how the color of the flakes are changing. We have flake glossiness, which controls the glossiness of the flakes. In the first render, flake glossiness was 0.6. then 0.8, and 0.95. Obviously, as you increase the glossiness value, the flakes will have sharper reflections and will be easier to spot. But remember, if you are rendering animation, make sure this value is not above 0.9 because it can cause flickering and artifacts. Let's set the flake glossiness to 0.8 again. We have flake orientation, which controls the orientation of the flakes relative to the surface normal. When set to 0, all flakes are perfectly aligned with the surface, and when set to 1, the flakes are rotated completely randomly with respect to the normal. Values above 0.5 are not recommended as they can produce artifacts. In the first render, flake orientation is 0, then 0.3, 0.5, and 1. Let's set it back to 0.3. Flake density controls how dense the flakes are going to be, basically how many flakes you want to have, and if you want to have no flakes, you can simply zero out this value. In the first render, flake density was set to 0, so no flakes, then 0.5, then 1, 2, and 4. As we increase the density, we are going to get more flakes. Now let's set it back to 0.5. Flake scale scales up or down the entire flake structure. In the first render, flake scale is 0.001, then 0.005, then 0.01, 0.05, and 0.1. You can see we are scaling the entire flake structure. You are not making the individual flakes smaller or bigger, you are altering the whole structure. Now let's set it back to 0.01. Now, flake size specifies the size of the flakes relative to the distance between them. Higher values produce bigger flakes and lower values produce smaller flakes. Now, this parameter controls the size of the individual flakes. In the first render, flake size was 0.1, then 0.5, 1, 2, and 4. Now the individual flakes are getting bigger and not the whole structure. Now let's set it back to 0.5 again. We have flake seed, which is a random seed to control the flakes distribution pattern. If you are not happy with the way the flakes are distributed, you can try different seed values here. We have flake filtering, which specifies what filter method to be used for filtering the flakes and produce a cleaner image and less artifacts. We have simple and directional. Simple is faster, less accurate, and requires less RAM, but directional is a bit slower, more accurate, and requires more RAM. The generated flakes you see here are stored in smaller bitmaps. Flake map size control the size of those bitmaps. Lower values reduce RAM usage but may produce noticeable tiling in the flake structure, and higher values require more RAM but tiling is reduced. Let's increase the flake size to 1 and take a look at a few renders. In the first render, map size was 64 pixels and you can clearly see the tiling. Then we have 512, 1024, and 2048. Now let's set the flake size to 0.5 and map size to 1024. We have flake mapping type to determine the method for mapping the flakes. If set to explicit UVW channel, the flakes are mapped using the specified channel, and if set to triplanar from object XYZ, the material automatically computes mapping coordinates in object space based on the surface normals. Flake map channel specifies the mapping channel for the flakes when the flake mapping type is set to explicit UVW. We have flakes trace reflections, and when disabled, the flakes will only produce specular highlights, but no actual reflections will be traced. Next, we have our reflective coat layer. And this layer in metallic CarPaint is supposed to be having very sharp but not that strong reflection. Coat color specifies the color of the coat layer. As I change it, you can see how the reflection color is changing in the perpendicular faces. And this is the render we are going to get with this red color defined as our coat color. We have coat strength, which is the amount of the reflection for the coat layer, and by default it's 0.05, which is very low, and it is supposed to be like that. And we have coat glossiness, which is set to 1, so weak but sharp reflections. We have coat trace reflections. When disabled, the clear coat will only produce specular highlights but no actual reflections. And finally, we have our options rollout, and we have discussed all of these options in the option rollout of the very material. So that's about CarPaint material. We have another material which is called Flakes material, and this material only generates the flakes, and it has no base diffuse and reflection and no clear coat. And you can simply use this material and blend it on top of another material. The way it works, you prepare your base material using very MTL or maybe a very CarPaint material or other materials. So let's add a simple very MTL in this case. Create a blends material and define very MTL as the base and flakes material as the coat. And now you can apply the blend material. Now the parameters in the flakes material are exactly the same as the flakes layer parameter rollout in the CarPaint material. So that's about it. I don't think we need any more explanation here. Another related material to the CarPaint and flakes material is the stochastic flakes material. So let's add one to the active view and assign it to our geometry. V-Ray stochastic flakes material is used to simulate the flakes in a CarPaint or any other glittery, sparkly surface like snow, decorative balls, and stuff like that, The way it normally works is like the flakes material. You use it in a blend material as a coat and assign your base material to the base slot of the blend material. Compared to the flakes in the CarPaint material or the flakes material itself, stochastic, it's faster, requires less RAM, and normally produces better results. And what you see in the render is the default state of the material applied directly without any blend material. In the parameters, we have enable flakes, and when enabled, the material simulates flakes scattered on the surface of the object, and when disabled, we only get a simple reflective layer with the defined glossiness and BRDF type down here. In the first render, enable flakes is on, and we get these very small and scattered flakes, and in the next one, enable flake is off, and we only get a simple reflection with a high Fresnel value. Let's make sure enable flakes is on. We have num flakes, which is the number of the flakes. By default, it's set to 3000, and the actual number is the square of the specified value here. So right now, 3000 by 3000, we are dealing with 9 million flakes. And the highest number you can go here is 46,340, which is about 2 billion flakes. In the first render, num flakes was 100. And you can clearly see the individual flakes, and as there is no base material for the flakes, we get a black background. Then we have 250, 500, 1000, and 3000. We have highlight glossiness, which controls the distribution of the flakes. Values closer to 1 will make all the flakes orient along the surface, whereas lower values will randomize the normals of the flakes. The first render was done with highlight glossiness set to 0.6, then 0.8, and 0.95. So you can see lower values result in blurrier highlights, and higher values will result in sharper highlights. Let's set it to 0.9 for now. Using material highlight glossiness, you can use a map to control the highlight glossiness value. Blur angle controls the softening of the flakes effect. Higher values produce softer results, while smaller values make the flake sharper. Usually values between 0.5 and 8 are used. The first render was done with blur angle of 0.5. Then 3, and finally 8. And as we increase the value, you can see the reflection is getting blurrier. We have subdivs to control the quality of the reflections. Reflection filter controls the reflection color for the flakes. Using reflection map, you can define a map to control the reflection color. I'm kind of increasing my pace here as I know these options are familiar and by now you know what they are doing. We have the exact mapping type and map channel options that we had in the CarPaint and Flakes material. We have flake scale, which scale the texture space or the entire structure of these flakes. To see how this parameter works a bit better, let's set the num flakes to 100 and now we can see a few renders. In the first render, flake scale is 0.1, then 0.5, and finally 1. And as you can see, by increasing the scale value, we are increasing the number of flakes as well. So it's not like the scale value in the CarPaint material. Let's set the num flakes to 3000 and scale to 1. We have Beckman and GGX model for the BRDF type. The first one was done with GGX and the next one with Beckman. Just a slight change in the way the highlight looks. And finally a random seed for the flakes using the seed value. Next we have our colored flakes parameters rollout. Colored flakes allows you to make the flakes colorful. By default it's set to off. If you set it to random hue, the flakes are gonna have different colors. And when set to random from map, randomized hue for the flakes will be based on a map, but only the bottom line of pixels of the map will be used. And you can define that map using random color map down here. Saturation determines the variance in color strength used for the flake colors when random hue is enabled. Lightness controls the brightness variation for the flakes color when random hue is enabled. For now, let's set the num flakes to 500 and this would be the render with random hue enabled. Now we get these colorful flakes. White average when enabled renders colored flakes without the darkening effect. In the render with white average off, we get this overall darkening effect, which is physically correct, but if you don't want that darkening, you can have white average on, which is our next render. In the advanced parameters rollout, we have blend min and blend max. Blend min specifies the number of flakes per pixel below which the flakes are computed. When the number of flakes per pixel is above this value, the material gradually transitions into a smooth BRDF. Blend max specifies the number of flakes per pixel above which the material will only compute the smooth BRDF. If the number of flakes per pixel is below this value, the material gradually transitions into discrete flakes. Just to have a simple final render, let's create a new V-Ray CarPaint material. Change the base color to a white color with the value of 245. Change the flake color to a white color with the value of 223. Maybe we can set the density to something like 0.5 and orientation to 0.15. Maybe flake size to 0.2. Now if we render the scene, we are gonna have our final render, which is render 01. In the next render, I completely turned off the flakes by zeroing out the flake density value, and the result would be render 02. We can check out the noiser pass as well. And let me just simply enable the white balance and cast out some cool tones by increasing the temperature to 8500. Perfect. So that's about V-Ray CarPaint, V-Ray Flakes, and V-Ray Stochastic materials. See you in the next lesson.